Question number 81. The closed loop transfer function of a control system is given by Cs by Rs is equal to 2 into s minus 1 by s plus 2 into s plus 1. For a unit step input, the output is. So here what is given? Given is a transfer function and we have to find out unit step output. So what is the output? Cs is equal to transfer function into input. So input is Rs and Rs is equal to given to be 1 by s, that is the step input. So what we are getting? 2 into s minus 1 by s plus 2 into s plus 1 into s, and if I do the partial fraction, what we will get? Minus 3 by s plus 2 plus 4 by s plus 1 minus 1 by s, and if we take the inverse Laplace transform of this one, this will be minus 3 e to the power minus 2t plus 4 e to the power minus t minus 1. So this is the output when unit step input is given. So here option 1 is the correct answer, option A. Next question number 82. Here is question number 82. Select the correct transfer function v0s by v1s from the following of the given network. So here network is given and v0 or v0 is the voltage across this inductor and v1 is the input voltage, and we have to find out what is the transfer function. So here first I have to find out the current. This is I in the total current provided by the source, and then this current will be divided into two parts, that is one part through the inductor and another through the resistor, and the current through the inductor and the inductive reactance multiplication will be the voltage output. So to find out the current, first we have to find out the total impedance. What is the total impedance? Total impedance will be 1 plus this 1 plus these two in parallel connection, So in Laplace transform, this will be 1, this will be 1, but this will be 1s, that is s only. So here I have find out Zs is equal to 1 plus 1 parallel s, and this will be finally 2s plus 1 by s plus 1. And what will be the current? Total current is will be vi of s by z of s, and this will be vi of s by 2s plus 1 by s plus 1, and this will be vi by s into s plus 1 by 2s plus 1, and current through L will be this current will be divided into two parts, one through inductor. So current through inductor will be total current into opposition is 1, that is the resistance here, and by total is 1 plus s, and this will be is by s plus 1. So what will be the v0s is s into is by s plus 1. Now what will be the transfer function? v0s by vis will be equal to, here v0 is s, what we are getting? s into is by s plus 1, and what is is we have find out already. Is this much, this much, and if I put this one, this will be s by s plus 1 into s plus 1 by 2s plus 1, and here s plus 1 will be cancelled out, and only there will be s by 2s plus 1 into vis, that is vis into s by 2s plus 1, and if we divide this one by vis will be cancelled out, and only s by 2s plus 1 will be remaining, and that is the transfer function. Option C is the correct answer, s by 2s plus 1. Next question is the transfer function v2s by v1s of the circuit shown below. So here is the circuit, and we have to find out the transfer function. Here this is also a similar problem, and here what is given? We have to first convert the electrical inputs, electrical components to Laplace components, and that means here 100 microfarad will be 1 by 100 micro into s, and 10 kilo ohm will be remain same, 10 kilo, and 100 microfarad again this will be 1 by 100 micro into s. This is not microsecond, this is S is the Laplace transform function, and here V2 by V1S is equal to, because here current output is open circuited, the same current will flow through this one, and how we can represent this one, Is into 10k plus 1 by S into 100 micro by Is into the whole, here the current whole, the voltage drop is V1 and the voltage drop only across the resistor and capacitor is V2. So V2 is Is into resistor and capacitor, but this one is the whole. So if we solve this one, what we are getting? We are getting simply the S plus 1 by S plus 2, and I am not here totally simplifying this one. I have already done this one. So this one is S plus 1 by S plus 2. Here option D is the correct answer. Next question, question number 84. Here question number 84. The mechanical system is shown in the given figure. Here is the mechanical system. The system is described as. So here we have to convert this one to mathematical form. This is a mechanical system given here. So first thing what we have to consider, here I have already marked this one. Here there is a fault in the options, because in the options there should be, here it should be plus, it should be plus everywhere, at least for the correct option. Here correct option is D, I am explaining how, but here what it should be, it was given like this, and what it should be, k into y1, here also k multiplied, and here bracket end, and here plus f1. So how this is coming? First for this one, damper, m into d square y2 by dt square. So here only y2 force is acting, and here also only y2 force is acting. So here m is mass, and d square y2 by dt square, and again for similarly for this one is B, this one is B and this one is m is the mass and B is the damper. So here for m also y2 force only acting, and for this one also y2 force only acting. So for these two, y2 will be the force, and is equal to, which will be equal to y1 minus y2, because up to this one y2 is the force acting, and at this point y1 is another force. Why we are taking y1 minus y2, I am explaining. Suppose this one is the spring, and if I put this spring, suppose this one is the rigid body, and I will put the spring like this, and this one is the y1 force. What will happen? Spring will expand, because this point, suppose this point is point A and point B. Point A is connected to a rigid body, and this will not move. So if I put y1 force, spring will expand. And if I will replace that rigid body with another force, suppose another force in this direction, this is suppose y2, what will happen? In this direction, what will happen? This also expands the spring, so the whole force on the spring will be y1 plus y2. But if I put the force like this one is y1 at the point B y1, and point A this will be y2 in the same direction. So this force will act as compression force, this force will act as compression force, this force will act as expansion force. So the total force or the effective force will be y1 minus y2 on k. y1 minus y2 on the k. So k into y1 minus y1 minus y2 plus f. F is the force, plus f is the force. So option D here is the clear answer, correct answer. And I want to clear that all the options are given wrong here. All the options are given wrong here, because in all the options here bracket should be started and here bracket should be ended, and here plus should be there, plus should be there. So here bracket and plus, because k is multiplied to both y1 and y2. Next question, what does the function ft plotted between the below the figure represent? So here this one is the plot, this one is the plot, and value is its magnitude is 1. So this is unit impulse function. Unit impulse function means its area is unity, because area is unity when we talk about only impulse function. That means it has infinite magnitude of 0 width. So this will have the area of 1, and here magnitude is also given like that one. So this is unit impulse function. Next is question number 86. The law or principle is in mechanical system. This is in mechanical systems analogous to Kirchhoff's law in electrical system is. This is D'Alembert's principle. This question was also asked in Coal India Limited also. Next question is the servo motor differs from the standard motors principally in that it has option is low inertia, correct answer is low inertia and high starting torque. Another characteristic of servo motor is low bearing friction. Because I remember these 3 points, servo motor has low inertia, high starting torque and low bearing friction, because these 3 terms have been many times asked in SSC JEE and also in ESE exams. Next question is the resulting equivalent transfer function of the system shown below. So here what is given, here is the block diagram is given, and we have to find out the transfer function. So first we have to find out the forward paths. What are the forward paths? One forward path here, and there is no other forward paths. So here G1 and G2 is the only forward path. Then 1 plus loops. And what are the loops here? Here is one loop and another loop is here. So G1 G2 is one loop, and here it is minus. So this will be plus 1 plus G1 G2 plus G1 G2 H1. Here option A is the correct answer. So next question number 89. The number of forward paths and the number of non-touching loop pairs for the signal flow graph given in the figure below are. So here what is asking for? Number of forward paths and number of non-touching loop pairs. So we have to find out non-touching loop pairs, not the non-touching loops. We have to find out the pairs. Generally what mistake students do is they find out the non-touching loops. Suppose there are 2 non-touching loops, there is one pair, 2 non-touching loop will be one pair, and they will not look at the pair word, and they will write it to be 2, but this is one pair, because here option 3 2 both are 3 2 and 3 1 both are present. So now what are the forward paths? First thing, forward path is this is one forward path, this is one forward path, another forward path is like this is another forward path, and last forward path is like this. These are the 3 forward paths. And what are the non-touching loops? Non-touching loop, this one is one non-touching loop, that is B, and another here these two loops are non-touching. So this is one pair of non-touching loops. So answer is 3 1 3 1. Next question is, the signal flow graph of a system is shown below. US is the input and CS is the output. Assuming H1 is equal to B1 and H0 is equal to B0 minus B1, B0 here, B0 minus B1 A1, B1 A1 here, B1 A1. The input output transfer function GS is equal to CS by US of the system is given by. So here we have to find out first the transfer function, and we have to then put the values for the H1, H0. So first, what are the forward paths? What are the forward paths? Here one forward path, simply another forward path here, here one forward path, second forward path. So now we have two forward path. One forward path is H0 into 1 into 1 by S into 1 into 1 by S into 1. Here is the one forward path. And another forward path is here H1 into 1 by S into 1, H1 into 1 by S into 1. This is the second forward path. And if we apply the Mason's gain formula, in the numerator there will be two forward paths first. Next we have to find out the loops those are not touching to the forward path. Loops those are not touching to the respective forward paths. So what are the loops that not touching the first forward path? First forward path is this one, and all the loops are touching to this one. So there will be only one. Second forward path is this one. Second forward path is this one. So is there any loop which is not touching to this forward path? Yes, this one is the forward path which is not touching to this. Yes, this is the loop which is not touching this forward path. So this is minus A1 into 1 by S, minus A1 into 1 by S. So here this will be 1 minus of minus A1 by S, and this will be 1 plus 1A by S. So this is the numerator part completed, and the second part is the denominator. And what is the denominator? Denominator 1 plus all the loops. Then what are the loops? 1 minus of minus loops, all the loops, single loops. Here is one loop and here is another loop. So here are two loops, and there is no non-touching loop. So here this will be minus A0 by S2, A0 by S square. Why? A0 by S square. A0 here, S square. Here is 1 by S into 1 by S. Here S square. This will be S square. So if we simplify this one, this is coming to be H0 or H0 plus H1S plus H1A1 by S square plus A0 plus A1S. This is the final transfer function, and we have to put the values. H1 is equal to B1 and H0 is equal to B0 minus B1 A1. So if we put these values, what we are getting in the place of H0, we are putting here we are putting B0 minus B1 A1 plus B1S plus A1 B1, because B1 is H1. So what we are getting? B1S plus B0 by A square plus A1S plus A0. So here answer is option C. Option C is the correct answer. Next is feedback control system are insensitive to both forward and feedback path parameter changes. Option B, less sensitive to feedback path parameter changes than the forward path parameter changes. Next is option C, less sensitive to forward path parameter changes than to the feedback path parameter changes. Option D, equally sensitive to forward path and feedback path parameter changes. So what is asking in this question? We have to find out the sensitivity of a feedback control system with respect to both forward path parameter and the feedback path parameter. So here is the given here is the given transfer function, the control system, and what will be the transfer function for this one? G by 1 plus GSHS. I am omitting the S. So here G by 1 plus GSHS, and here I have taken negative feedback system because generally we take negative feedback system for better control. Now what is the sensitivity? Sensitivity with respect to the forward path system, forward path parameter. What will be the sensitivity? Sensitivity of M. M is the transfer function. M is the transfer function by M, and here G. G is the forward path parameter. This will be del M by M by del G by G. Del M by M by del G by G. And change in transfer function by change in the forward path parameter. This is the sensitivity. And what we are getting here, this can be finalized as G by M del M by del G, del M by del G. And if we put the value of M, what we are getting? Finally we are getting 1 by 1 plus GH, 1 by 1 plus GH. Similarly, sensitivity to feedback path. What will be the sensitivity to feedback path? This will be del M by M by del H by H, and this will be H by M into del M by del H. And if we put the value of M and then differentiate, what we are getting? Minus GH by 1 plus GH. So what we are getting, if we take the mod, because we are going to compare the sensitivity parameter, not the negative positive sensitivity. Here this value and this value, if we compare, this value will be always mod of this value, mod of second one, that is the sensitivity to feedback path will be greater. Sensitivity of a feedback path will be greater than that of sensitivity to forward path. So here answer will be C, that is feedback control system are less sensitive to forward path parameter changes than to the feedback path parameter changes. So here option C is the correct answer. Next question number 92. Given the transfer function g of s is equal to 121 by s square plus 13.2s plus 121 of s system, which of the following characteristic does it have? So here second order system is given and we have to find out all of its parameters. So first thing, this one is the omega n square. So omega n square is 121. So omega n will be root over of 121, that is 11. And then 2 zeta omega n s, this one is 2 zeta omega n s. So 2 zeta omega n s is equal to 13.2. 2 into 11 into zeta is equal to 13.2, and zeta will be equal to 13.2 by 2 into 11, that is 22. And here what we are getting, zeta is to be 0.6, which is smaller than 1 and greater than 0. Hence this is underdamped system. So what are the underdamped system given? Here one is underdamped, here one is underdamped, another here is underdamped. So two options are given in terms of underdamped, and what are given? Settling time is given. Settling time is different in both the options, so we have to find out the settling time. So for settling time, 99%, I have forgotten what is the error. What is the accuracy to the final value? TS will be 4 times that of time constant. And what is the time constant? 1 by zeta omega n, and 4 into time constant is equal to 4 into 0.6, that is the zeta, into 11. 11 is the omega n, and what we are getting? 0.606 is the settling time. So here for underdamped system, 0.6 second is the settling time. So here option B is the correct answer. Next question number 93. Here in this question given that if a ramp input is applied to a type 2 system, the steady state error is. So this is a very simple question. If you have remembered this table, and you will answer this clearly. So what is given? Type 2 system. Type 2 system steady state error. What will be the steady state error? So here type 2 system. Type 2 system, and what is the input? Ramp input. So answer will be 0. Simply answer will be 0. So what we have to remember? For step input and type 1 system, the answer will be steady state error will be constant, and this will be 1 by 1 plus Kp, and here Kp is the positional error constant. And similarly for type 1 system and ramp input, steady state error constant will be 1 by Kv, and Kv is the velocity error constant. Similarly for parabolic input and type 2 system, steady state error will be 1 by Ka. Ka is the acceleration error constant, and so these are the constant values, and above that this will be infinite. So here answer is 0. Next question is, what will be the type of system if the steady state performance of the control system yield a non-zero finite value of the velocity error constant? Non-zero finite value of the velocity error constant. Velocity error constant is non-zero. That means what is velocity error constant? Velocity error constant is defined as Kv is equal to limit s tends to 0 s into GSHS. So this is velocity error constant. And how we represent GSHS? GSHS is generally represented by K into 1 plus Z1s. Z1 is the one pole. Similarly there will be other values, and by in denominator there will be s and the power of s represents the type of system into 1 plus p1s, and like this other terms will be present. And what is in this question given? What is the type of system? So here if there is s, then if here we put this value, this s, and here denominator there will be s, this will be cancelled out, and all the value s tends to 0. That means this value and other values will be 0, and we will get a constant value for Kv. So this will be type 1 system. Suppose here we are getting s square. Suppose here is s square. So what will happen? Here there is s and here s square. What will happen? This s will cancel out to be s, and in the denominator there will be another s. So what will be the velocity error constant? Velocity error constant will be infinite. And what is the steady state error? Steady state error will be 0. Next question. Consider the unit step response of a unit feedback control system whose open loop transfer function is Gs is equal to 1 by s into s plus 1. The maximum overshoot is equal to. So here what we are given that only Gs, that is open loop transfer function, is given. We have to find out the characteristic equation to find out the maximum overshoot. So what is the characteristic equation? Characteristic equation is given by 1 plus Gh is equal to 0. And h is given to be unit feedback, that means 1. So 1 plus Gh is equal to s into s plus 1 plus 1, that is denominator here, plus 1 is equal to 0. And here this is coming to be s square plus s plus 1 is equal to 0. So here omega n square is equal to 1, that means omega n is equal to 1. 2 zeta omega n s is equal to 1 s, that means 2 zeta omega n is equal to 1. Zeta is equal to 1 by 2 omega n, which is equal to 1 by 2. Now what is the formula for maximum overshoot? Maximum overshoot is equal to exponential of minus zeta pi by 1 minus zeta square. So if we put the values, exponential of minus zeta value is 0.5, pi by 1 minus 0.5 square, and what we are getting? 0.163. 0.163 is the correct answer, option C. Next question is, transfer function of a system is given as 100 by s square plus 20s plus 100. The system is. So here what are the options? An overdamped system, overdamped, critically underdamped, stable system, unstable system. So here this is the characteristic equation. Similarly we will find omega n is equal to 10, 2 zeta omega n is equal to 20, zeta is equal to 20 by 2 into 10, which is equal to 1, 1 means critically damped. So question number 96, option option C will be the correct answer, critically damped. Next question is, the dominant poles of a servo system are located at S is equal to -2 plus minus J2. The damping ratio of the system is. So what is the damping ratio of the, if the dominant poles are located at -2 plus minus J2? So here is the plot, and what are the poles? Here is one pole, dominant pole, and another is here, -2 plus J2, -2 minus J2. So what are the what is asking for? This is asking for the damping ratio of the system, that means zeta. What is the zeta value? What is the zeta value? So roots are in the left side of the S plane. So and complex conjugate, that means this is underdamped, that means this is underdamped. I will explain all the things why this is underdamped. Now we will see, for underdamped system, root of the characteristic equation is given by root of the characteristic equation is given by simply this one, minus zeta omega n plus minus j omega d, and omega d is equal to omega n into 1 minus zeta square. What is omega d? Omega d is the damped natural frequency, omega n is the only natural frequency. So this is the real part, and here given to be real part to be 2, -2, minus zeta omega n is equal to -2, so zeta omega n is equal to 2. And here in the second part, omega n into 1 minus zeta square is given to be 2. And here what we will find, if we divide this by this, so what we will get, 1 minus zeta square root over by zeta is equal to 1, and this will be if I take square of both the side, 1 minus zeta square by zeta square is equal to 1, and what we are getting, zeta is equal to 1 by root 2, and this is equal to 0.707. So here answer will be 0.707. So now we will explain how this is an underdamped system. If the roots are like this will be underdamped system. So what will be the other conditions? So here I have already explained, I will only show this one. Look at the colors. So here this one is real axis, this one is imaginary axis, and if the roots are on the imaginary axis and of conjugate, that means they are what we can say, that symmetry to the origin or the real axis. So what will happen, this is pure imaginary. So for pure imaginary means this is critically stable, marginally stable, and this is system is marginally stable, and this is undamped. Undamped means the system will have like this, have a constant frequency and constant amplitude. And next is if the complex conjugate pole, like this question, here is the complex conjugate poles. What will this indicate? This indicates zeta value from 0 to 1, that means underdamped, and the system is stable. If the poles are double negative real pole, like this, here the poles are same but on the real axis and negative. So what this indicates? This indicates critically stable, that means zeta is equal to 1, and the system will be like this. Suppose this one is 1 final value, this will be like this, critically stable. And final is on the real axis, but two different values. On the real axis, unequal negative poles, and what is its indicate? Zeta is greater than 1, that means overdamped system, and this is stable and pure exponential but slow, and this will be like this, critical. This one is critical, and this one is overdamped. So now we will go for the next question. Next question is 98. In the formation of Routh-Horowitz array of a polynomial, all the elements of a row have zero values. This premature termination of the array indicates the presence of option A, only one root at the origin, option B, imaginary roots, only positive real roots, only negative real roots. So all the elements of the row have zero values. All the elements of the row are zero values. That means this is symmetry. This indicates the symmetrical roots with respect to origin. Symmetrical roots with respect to origin. That means imaginary roots. I have already explained in the above question that are imaginary roots, and this will be marginally stable or unstable. If double roots are present on the imaginary axis, this will be unstable. Using Routh-Horowitz criterion, the number of roots in the right half S plane of the characteristic equation s to the power 4 plus 2s cube plus 2s square plus 3s plus 6 is equal to 0 is. So we have to find out the number of roots in the right half of S plane. So we will form the Routh-Horowitz criterion, that is Routh-Horowitz array, and this is s4, s3, s square, s to the power 0, and we will arrange the coordinates, and here first 1, then 2, this 2, and then 6, another is 2, 3, 2, 3, and how is a half is 2 into 1, 2 into 2, 4 minus 1 into 3 by 2, this is half, and this is again half into 3, that is 3 by 2 minus 6 into 2, that is 12 by half. What we are getting minus 21. So here what we are getting, sign changes. We will consider the sign changes of the first column of Routh-Horowitz array. So here plus half to minus 11, one sign change, and again minus 21, sorry, this is 21, minus 21 to plus 6, another sign changes. So here two sign changes are occurring. So what will be the number of roots in the right half of S plane? This will be 2. Right half of S plane is 2. Next question number, sorry, I have left 99, sorry, okay. Next question number 100. A closed loop system has characteristic equation given by s cube plus k s square plus k plus 2 into s plus 3 is equal to 0. For this system to be stable, which one of the following conditions should be satisfied? So this should be stable. So here we will construct the Routh-Horowitz array. So here s cube, s square, s1, s0, and here 1 k plus 2, 1 k plus 2, 1 k plus 2, and here k3, and now what we will again do the same thing, k into k plus 1 minus this one 1 into 3 by k into k plus 2 minus 3 by k, and this is coming to be k square plus 2k minus 3 by k, and this 3 will be here, So for the system to be stable, all the elements in the first column of the Routh array will be greater than 0. So here first condition is k here should be greater than 0. First will be k is greater than 0. Again this should be greater than 0, that is k square plus 2k minus 3 by k should be greater than 0. So if we put this one as k is greater than 0, we can multiply in this side, in the right hand side, and this will be k square plus 2k minus 3 greater than 0, and k square plus 3k minus k minus 3 is greater than 0. If we simplify this one, this will be k plus 3 into k minus 1 is greater than 0, and here k plus 3 is greater than 0, that means k is greater than minus 3. Again k minus 1 is greater than 0, that means k is greater than 1. So we are getting three conditions. One is k greater than 0, another is k greater than -3, k greater than 1. So what is the ultimate condition? Ultimate condition is k greater than 1, which will also apply to k greater than 0 and k greater than -3. So here option D is the correct answer, because here k greater than 1 plus 1. Adding of open loop poles results into which one of the following? Option A, root locus shifts towards imaginary axis. Option B, root locus shifts away from the imaginary axis. Option C, system stability increases. Option D, system becomes less oscillatory. So here answer is directly the root locus shifts towards imaginary. If we add open loop poles, next question is, the root locus of a feedback control system having the characteristic equation s square plus 6ks plus 2s plus 5 is equal to 0, where k is greater than 0, enters into the real axis at. So if the root locus enters or breaks away, comes away from the real axis, that is called break away point and break in point. That ultimately this is called break point. And how we can find out the break point? Here is the method. We have to express the characteristic equation in terms of k is equal to something. So then we have to find out dk by ds, that means differential of k with respect to s, and then we have to equate it to 0. So what we will get now, a square plus 6s plus 25 plus 2s plus 5, this is not 25, 2s plus 5 is equal to 0. So here minus 6s is equal to s square plus 2s plus 5, and k is equal to s plus 2 plus 5 by s minus 6. This is the k. And if we differentiate this one with respect to s, this will be minus 1 by 6 into 1 minus 5s square is equal to 0. And then we have to find out what is the value of s. So what we are getting? We are getting the value of s to be plus minus root 5. So here two values we are getting, and both the values are given in the options. Here minus root 5 also given, plus root 5 also given. So we have to find out what is the correct answer. First thing, this one is a stable system. For because here given that k is greater than 0. This will be a stable system, and we can verify this from the Routh array. For k is greater than 0, whole the first column will be greater than 0 and no sign change will be there. So this is a stable system, and root are in the left side. As there is a left side roots, the breakaway point will be on the real axis, and this will also in the left side. So here minus root 5 will be the correct answer. Minus root 5 is the correct answer. Next question number 103. The root locus of a unit feedback system is shown in the figure. Here is the root locus. The closed loop transfer function of the system is. Here the root locus is given and asking for the transfer function. Here two poles are given, -2 and -1, and direction from pole to 0 are considered to be 1 0 at plus infinite, another is at minus infinite to zeros. So here we have to find out the transfer function. So here poles are -2 and -1, 0 is at infinite and minus infinite. So GSHS, that is the open loop transfer function, will be this one, that is k by s plus 2 into s plus 1. For hs is equal to 1, the negative feedback system, this is simply the transfer function, because these are the poles, this will be the transfer function k by s plus 2 into s plus 1. And for negative feedback system, what will be the transfer function? Whole transfer function, that is the system transfer function, C by R. C by R is G by 1 plus GS. 1 plus GS. This is for negative feedback system. Generally we use the negative feedback system, K by S plus 2 into S plus 1 plus K. And for positive feedback system, this will be G by 1 minus GH, and this will be K by 2 plus S plus 2 into S plus 1 minus K. This one is the things we are getting. So what will be the answer? Because in the options both are present, K by S plus 2 into S plus 1 plus K, and here is K by S plus 2 S plus 1 minus K. Minus K is also present, plus K is also present, plus K is also present. So what will be the answer? What will be the correct answer? So to find out this one, we have to see what type of system this is. This is for suppose for a positive feedback system. For positive feedback system, what we are getting, if we construct the Routh array, this will be 1 2 minus k, 2 minus k, 3 2 minus k. And for the for this is to be what? This is to be marginal stable. That means for marginal stable, k will be equal to 2. And for this one, for negative feedback system, this will be 1 2 plus k, 3 2 plus k, and here k will be equal to minus 2. And in case of root locus diagram, k, negative value of k is not allowed, because from if we see this one, from 0 to infinite, from 0, the k value is at pole, k value will be 0, and at 0 k value will be infinite, positive infinite. Not the negative values of k is considered in case of root locus diagram. And what is the root locus represents? Root locus represents the variation of a k, variation of a k as the result of the roots, how the roots are varying with respect to variation of k. This is the root locus diagram presents. So as what we are getting that for negative feedback system, for marginally stable, k is to be minus 2, and this is not possible, because root locus diagram is only for k value to be positive. So here the answer will be the positive feedback system, which is rarely used, and the answer will be k by S plus 1 into S plus 2 minus k. Here is the answer. If in the question, suppose is in the question, here in the given negative unit feedback, here also given, suppose negative or positive, suppose here given positive feedback system. So answer will be this one. Answer will be this one. If in the question itself is given negative feedback system, then question will be wrong, because we cannot define k to be negative in root locus. So next question is 104. A unit feedback system has the open loop transfer function GS is equal to 1 by S minus 1, S plus 2, S plus 3. The Nyquist plot of GS encircles the origin. So number of encirclement by the Nyquist plot is given by the poles, number of poles in the right hand side minus number of zeros in the right hand side of S plane. So number of poles in the right hand side, here what are the poles? Here is 1, minus 2 and minus 3. What are the poles in the right hand side? Only this one. So what is the number of poles in the right hand side? Number of poles in the right hand side is 1. And what are the zeros? There is no zeros. So what are the number of zeros in the right hand side? No zeros in the right hand side, so this will be 0. So 1 minus 0, this is 1. So 1 encirclement, so this encirclement will be ones. Next question is question number 105. Question number 105. So in this question, what is given? The Nyquist plot of loop transfer function GSHS of a closed loop control system passes through the point -1 J0 in the GSHS plane. The phase margin of the system is, what is the phase margin? So Nyquist plot of the transfer function, loop transfer function, I have to thicken this one. Yes, closed loop transfer function passes through the point -1 J0, so this will be like this. This may be look like this, minus J0. So this indicates that this is passing through -1 J0, means GSHS at gain crossover frequency, the value magnitude will be 1. That means at gain crossover frequency, this is the definition of gain crossover frequency. GSHS angle of GSHS will be -180. And what will be the phase margin? Sorry, this is not phase margin. Okay, this is phase margin. And phase margin is 180 minus this angle. 180 minus the angle at gain crossover frequency. And what we are getting the gain crossover frequency? This is -180. So this is 180 minus 180, which is equal to 0. So angle phase margin of this system will be 0 degree. Next question is, the frequency response of a linear system Gj omega is provided in the tabular form below. The gain margin of the system, gain margin and phase margin it is asking for. So we will define first what is gain margin and what is phase margin, then we will go for the problem. So what is gain margin? Gain margin is, this one is the definition of a gain margin. Gm is equal to 1 by m. M is the magnitude at omega pc. Omega pc is the phase crossover frequency, and this is 1 by m at omega pc, and in decibel form 20 log gm. This is in terms of decibel. Next is phase margin. What is phase margin? Phase margin is 180 plus angle of j omega h j omega at omega gc. Omega gc is the gain crossover frequency. Here omega pc and here omega gc, and we will define what is omega pc, that is phase crossover frequency. Omega pc, that is phase crossover frequency, is the frequency at which phase plot intersects -180 degree line. This is the phase crossover frequency. And what is the gain crossover frequency? This is frequency at which magnitude plot crosses 0 dB or unity line. 0 dB or unity line. So gain margin is equal to 1 by m at omega pc. So this will be equal to what is omega pc. So here if we see omega pc is equal to, look at this one, -180. At -180 line, what is magnitude is 0.5 -180. So -180 is omega pc. So at -180 crossing omega pc, and what we are getting from omega pc we are getting gm is, so magnitude will be 0.5. so magnitude will be here given j omega. This is magnitude is given to be 0.5. so here gm will be 1 by m at omega pc. That is -180. This is 0.5 and this is 2. 1 by 0.5, that is 2. And in terms of dB, that is decibel, 20 log 2. This is 6 dB. So here gain margin we are getting 6 dB. And now Gj omega Hj omega at omega Gc is equal to Gj omega at so here what we are getting, omega Gc. Omega Gc is frequency at which magnitude plot crosses 0 dB or unity line. So at unit line means magnitude will be unity, and what is the angle? Angle is -150. corresponding angle is minus 150. So what will be at omega gc, what is the angle is minus 150. So what will be the phase margin will be 180 minus angle at omega gc, that is gain crossover frequency. So this will be 180 minus 150, which is equal to 30. So here are the answers: 6 dB and 30 degree. 6 dB and 30 degree. Option A is the correct answer. Next question number 107. Question number 107. The phase crossover frequency of the transfer function Gs is equal to 100 by s plus 3 whole cube in radian per second is. So here what is given? 100 by j omega plus 1 whole cube given. So here j omega is given to be this one, and if we find out the angle, its angle, so this will be minus 3 into minus 3 is the power minus 3 into tan inverse of omega pc by 1 is equal to minus 180, because at omega pc, that is phase crossover frequency, angle should be minus 180. My angle should be minus 180, phase crossover frequency minus 180 angle. Already I have explained this one. So here tan inverse of omega pc will be equal to 60 degree. Omega pc is equal to tan of 60 degree, which is equal to root 3, So here option A is the correct answer. This is asking for phase crossover frequency. Next question is Bode phase angle plot of a system is shown below. The type of the system is. So we cannot determine actually what is the type of system from this type of a phase plot if nothing is given. Suppose this value should be given, then we can analysis. But if no omega value is given and nothing is given, only the shape of this one is given and the position is given, we cannot analyze what is the type. But we can remember the filters, the phase plots of the filters, and in that way you can analyze. So here answer is this is a all pass filter, and this all pass filter has the form like this, and so there is no term of s to the power 0 is in the denominator. This will be a type 0 system. This is a type 0 system. So why we are going for the filters? Why we are going for the filter phase angle plots? So here are the filters. So if we say about the high pass filter, its magnitude plot is like this. Magnitude plot is like this. And similarly the high pass filter, and here the low pass filter has magnitude like this. This is totally opposite. But in case of the phase plot is similar in case of both. The plots. That means, but the main thing we have to remember is here high positive value, starting from high positive value, and here when it is equalizing, or here the saturated value, saturated phase angle, this is low negative value. Suppose high means, suppose this one is 90 degree and here minus 5 degree. This is the angle values. High positive at the starting, low negative at the ending. So this is the high pass filter. And if we consider the low pass filter, here this will be low negative, here this will be no low negative, and here this will be high negative, low positive, high negative. That means suppose this one is 5 degree and this one is minus 90 degree. This is the difference between the phase plots of a low pass filter and a high pass filter. So what we are getting for high pass filter, the phase plot will be like this. From high positive value, you can remember this. Suppose this one is 90 degree, this is minus 5 degree. So, and this is low positive value to high negative value, 5 degree to minus 90 degree. So this is for low and high pass filter, and high pass filter. So what is given here? It is given like this, from 0 to minus 180, and it is starting from 0. And in case of both the cases, it is not starting from 0. it is not starting from 0. That means non-zero phase value is not starting here. So we have to remember this one. So for this one, this is all pass filter. For this is all pass filter, and this is a type 0 system. And we another thing we have to remember this one. We cannot analyze the type of the system from this phase plot if omega values and corresponding phase angles are not given. Next question is question number 9. What is the initial slope of Bode magnitude plot of type 2 system? Type 2 system means the general representation of a type 2 system. GSHS is equal to K into 1 plus SZ1 S1 plus SZ2 and like that by S square. S square means this is a type 2 system, 1 plus SP1 into 1 plus SP2 and like that. So here corner frequencies are 1 by Z1, 1 by Z2, 1 by P1, 1 by P2 and so on. So smallest corner frequency is 0. Smallest corner frequency is 0 because there is S square. And what will be the starting slope? Starting slope will be 2 into minus 20. 2 is the slope of, and this is in the denominator. So this will be 2 into minus 20 dB per decade, and this will be minus 40 dB per decade. This is the procedure to find out what is the initial slope in a Bode plot. So here answer will be C. Next question, question number 110. Question number 110. A second order control system has m j omega is equal to 100 by 100 minus omega square plus 10 root 2 j omega. So its MP, peak amplitude is. So here what is asking, MP is the, MP here is the resonant peak, not the peak overshoot. Here it should be written in like that, MR, that is resonant peak, because this is in a frequency term, omega term. So first we have to find out. So if we convert j omega to s, j omega is equal to s and put that one, so this will be 100 by s square plus 10 root 2 s plus 100, and omega n square is equal to 100 and omega n is equal to 10. 2 zeta omega n is equal to 10 root 2 and zeta is equal to half, 1 by root 2, that is equal to 0.707. And what is the resonant peak formula? Resonant peak formula MR is equal to 1 by 2 zeta into 1 minus zeta square whole root 2 over. So if we put these values, 2 into 1 by root 2 into 1 minus half whole root 2 over, and this will be 1 by 2 into 1 by root 2 into 1 by root 2, and this will be finally 1. Finally this will be 1. So the second this system has the resonant peak is equal to 1. This is resonant peak MR, resonant peak MR. If asking for resonant frequency, so it will be omega n into 1 minus 2 zeta square. This is the formula. This is not asking here, but this will be 0.174. Next question is, the transfer function GS of a compensator is given below. The frequency range in which the phase lead introduced by the compensator reaches the maximum. So we have to find out the maximum phase lead in which of the frequency range. So here is the given one. Here is the given open loop transfer function, and what are the corner frequencies? Corner frequency, this is in standard form, already in the standard form. So what are the corner frequencies? 0.1, again here 1, and here 10, and here 100. These are the corner frequencies. At the corner frequencies we have to find out the Bode phase plot, because here asking for the phase lead, maximum phase lead in which of the frequency range. So here 0.1 is at 0.1 slope will be 20, because 0.1 is here, and this is in the numerator, so this will be 20 into 1, and the phase angle will be 90 degree into 1. So this will be 20 and this will be 90. And again next corner frequency is 1, which is in the denominator part. So due to its denominator part, this will be minus 20 into 1 because power is 1. So what is the net slope? Net slope here 20 plus minus 20. Here net slope is 0. And what is the phase angle? Phase angle for this one is minus 90. And what is the net phase angle? Here 90 and here minus 90. So this will be 0. And again this will be 10 for corner frequency 10. Corner frequency 10 is also in the denominator and its power is 1. So what will be the slope? Slope will be minus 20 into 1 because power is 1. And what will be the phase angle? Phase angle will be minus 90 into 1. So as this is in the denominator, this will be minus 20 instead of a plus 20. So what is the net slope? Net slope here is a 0. 0 plus minus 20. 0 plus minus 20. This will be minus 20. And what is the net phase angle? Net phase angle here is the 0. Here is 0 plus minus 20, minus 90. This will be minus 90. Up to this net slope is minus 20. Net phase angle is minus 90. Again, next corner frequency is 100. Is 100. 100 is in the numerator part and it has also the power of 1. So slope will be plus 20 and phase angle will be plus 90. And what will be the net slope? Net slope will be the previous net slope plus current slope. So this will be minus 20 plus 20. This will be 0. And what will be the phase angle? Net phase angle minus 90 plus 90. This is also 0. So what we are getting, this is the summary, and you will plot the Bode phase plot. So here phase angle plot, x-axis represents the omega in terms of log omega, and this is the phase angle in degrees, in the y-axis. So as this is in representing, we are in log omega, 0 cannot be represented. So we are starting from 0.1, then 1, 0 and then 100. These are the corner frequencies. This one is 10 and this one is 100. So first what is the net one? Here phase is 90, next phase is 0 and net phase is 0, 90, 0, again minus 90, 0. So here we will represent this one 90 up to 1, then 0, again 90, minus 90 and again 0. So this plus 90 represents the phase lead, and this negative 90 represents the phase lag. So what is in the question given? That the frequency range in which the phase lead introduced by the compensator reaches the maximum. So you have to find out where in which ranges there are phase lead and what is the maximum phase lead and which frequency section. So here in this section only we are getting the phase lead, and this is of 90 degree, phase lead 90 degree, and what is the frequency range? 0.1 to 1. In this range 0.1 to 1 we are getting maximum phase lead. If this has asked for phase lag, then this will be of range 10 to 100. This will be of range 10 to 100. So next question is introduction of integral action in the forward path of a unit feedback system results in a marginal stable. Option B, system with a no steady state error. So in this answer is option B, that is for integral system inclusion what we will get? Type increases, because integral is represented by 1 by s. So if we multiply 1 by s, the type of the system will increase, and what will happen? Steady state error will decrease. The system with a no steady state error is the correct answer here, option B. Next question is question number 113. The phase lead compensation used to. Option A, increase rise time and decrease overshoot. Option B, decrease both rise time and overshoot. Option C, increase both rise time and overshoot. Option D, decrease rise time and increase overshoot. So here answer B is the correct answer, that is decrease both rise time and overshoot. So in case of lead compensation, bandwidth increases and the rise time decreases, that is the maximum overshoot also decreases, and zeta, that is the damping ratio, improves. Damping ratio improves, that means it goes towards 1. Next question, question number 14. Which of the following is not correct reason to select feedback compensation over cascaded one? Option A, no amplification is required as the energy transfer is from higher to lower level. This is wrong. Suitable devices are not available for compensation, series compensation. This is also not correct. Next thing is, it is economical. So this one is the correct answer. It is economical. And last one is provide greater stiffness against load. This is also wrong. Next question is question number 115. What is the effect of lag compensator on the system bandwidth and signal to noise ratio? So answer is bandwidth reduces and signal to noise ratio improved. Next question is question number 116, that is 116. Consider the second order system whose state space representation of the form x dot is equal to ax plus bu if x1 of t, this is x1 of t is equal to x2 of t, then the system is uncontrollable, controllable, observable, unstable. So here what is given? x1 of t is equal to x2 of t. What are the x1? These are multiple variables. x1 of t, multiple inputs. x1 of t is equal to x2 of t. Then x1 derivative of x1 will be equal to x2 derivative. So if we represent this one in terms of state space representation, what will happen? x1 dot x2 dot is equal to a b c d, this is the A matrix, into x1 x2, this is x, and this is b. And now b I have represented two terms E and F. And controllability matrix, what is controllability matrix? B A B, this is the controllability matrix. Suppose I am representing to be MC, and what is AB? AB is the multiplication of A, that is A B C D, into EF. EF is the B. So if we multiply AE plus BF by CE plus DF, this is AB. So now what we have already known, that x1 is equal to x2. If x1 will be equal to x2, then what will happen? Here x1 will be equal to x2. This one is equal to this one. This one is equal to this one. So what will happen? A plus B, because this one also will be equal to this one. This one is equal to A x1 plus B x2. And again x2 dot will be C x1 plus D x2. So what will happen? As x1 is equal to x2, A plus B will be taken common, and x1 will be x2 will be outside. So what will happen? It will result AB is equal to CD, and due to this E will be always equal to F. E will be always equal to, what are the E and F? E and F are the elements of B matrix. So what is the MC mod? That is MC is the controllability matrix, and its mod, that is the magnitude, at the magnitude or the determinant will be E AE plus BF F CE plus DF is equal to 0, because this one is equal to this row. These rows are equal. Hence this is uncontrollable. Option B is the correct answer. These are all gate questions, previous year gate questions. A transfer function has its 0 in the right half of a S-plane. The function is positive real, is minimum system, will give stable impulse response, is non-minimum phase system. So here this is the definition of non-minimum phase system. That means 0 in the right half of S-plane. This is non-minimum phase system. Next question is question number 18. Question number 118. That is a system described in the function state equation x dot is equal to ax plus bu. The output is given by y is equal to cx, where a is equal to -4 -1 3 -1 and b is equal to 1 1. The c is equal to 1 0. The transfer function gs of the system. Transfer function, we know the formula is c into si minus a inverse into b plus d. This is the transfer function formula we know. So we have to find out this one and do the matrix calculations. So what is si minus a? Si minus a is equal to s plus 4, because here is -4, s plus 4 1 minus 3 s plus 1, and si minus a inverse is equal to 1 by s plus 4 into s plus 1 plus 3, and this one is the inverse. What is the inverse? Inverse is the adjoint of matrix by its determinant. It is the determinant value. And what is the adjoint? Here this is an adjoint for 2 cross 2 matrix. 2 cross 2 matrix, that means these two will be interchanged and this will be remain same, but its negative positive value, that is the polarity, will be changed. So here transfer function will be, this one is c into si minus a inverse into b plus d. As d is not given, this is 0. D is not given, this is 0. So if we multiply this one 1 0 with this one, this will be s plus, this is 1 cross 2 matrix, this is 2 cross 2 matrix, 2 cross 2 matrix. So its result will be 1 cross 2 matrix, 1 cross 2 matrix. What we are getting? S plus 1 minus 1. Here 1 into s plus 1, 0 plus 0. Then again 1 plus minus 1, here -1 plus 0. So what we are getting? S plus 1 minus 1 into, here this one is b. So again if we multiply this one, this is 1 cross 2, this is 2 cross 1. So answer will be 1 cross 1 matrix, and 1 cross 1 matrix means this is one scalar quantity, not a vector quantity, and a constant quantity. So this will be s plus 1 minus 1, s plus 1 minus 1, and this will be finalized to be s by s square plus 5s plus 7. So here answer is option A. Answer is option A, s by s square plus 5s plus 7. Next question is, the system matrix of the linear time invariant continuous time system is given by A is equal to 0 1 minus 3 minus 5. What is the characteristic equation? Simply the characteristic equation is given by si minus a mod is equal to 0. So this will be s minus 0 minus 1 plus 3 s plus 5 is equal to 0, and if we find out the determinant, s into s plus 5 plus 3 is equal to 0, and this is a square plus 5s plus 3 is equal to 0. So this is the characteristic equation. Option A is the correct answer. So next question, question number 120. This is the last question of this session. This question is given, which of the following system is correct in respect of a figure given below. So here is the figure given, and this is given that j omega, and I don't know what is this, minus 1 by k kilonewton or anything. I don't know what is this one, and I don't know what are the options given also. A and B are stable limit cycles. I don't know about limit cycles. Honestly. So this is I think if this one is a Nyquist plot system, then this will, and here suppose if this is given to be -1, and if this is encircling -1, then we can say that B is stable and A is unstable. So like that I am selecting option C. A is unstable limit cycle, but B is stable, but I don't know, I am not clear about this question. So if you know about this question and how to solve this one, please comment. So this is the end.